So keeping with the theme of DOM manipulations, Kapaya from MIT is going to tell us about customizing the websites you visit. So you visit a website, you can customize it using this tool called Joker. So hopefully you can share your screen and take it away.
Yep, let me go ahead, share my screen and start the presentation. And, all right, we're at the beginning. So my name is Kapaya, and I'll be talking about some of the ideas I developed while a master's student at MIT that are related to making the malleability of the web more accessible to more of its users. And this is work that was done in collaboration with Geoffrey, Litt, Kathryn, and Daniel Jackson at MIT's software design group. Now, a lot of us have probably been on websites that have not met all of our exact needs. If we look at the screenshot on the right, we see one of MIT's course catalog websites, which contains a list of courses. And even though some of these websites or some of these course listings can have courses that number in the hundreds, the website does not provide a way to sort the courses by fields such as whether a course has a prerequisite. Now, the good news is that you can write JavaScript to add behavior to websites because websites are malleable. The bad news is that you need to know JavaScript and probably a bit of HTML and CSS to add behavior to websites and take advantage of their malleability. I want to show you one idea for how we can add behavior to websites and take advantage of its malleability without resorting to JavaScript. And so I'll start out by showing a demo of the idea that we developed on MIT's course catalog website, where we will sort the course catalogs, the courses by whether courses have a prerequisite or not. And so exiting the slide, I will go to MIT's course catalog website. And if we just take a moment to think about the task at hand, which is we have this list of courses and we want to be able to sort by whether the courses do not have any prerequisites, how would we do this? Now, one way we could do this is start out by collecting all the courses and the course prerequisite information, and then somehow reaching into the website and moving the courses around based on whether they have any prerequisites or not. Now, I can imagine that if you could reach into your laptop to affect a website, sorting courses would probably be the least of your priorities. But let me show you our idea, which gets us close to that. And so we start out by opening Chrome's browser context menu to initiate Joker, which is the browser extension that we implemented to showcase these ideas. And so I'll go ahead and initiate Joker. And as I said, the first step is to collect all the course informations, and in particular, the field that has prerequisite information. With the Joker, I can do that simply by hovering over values. And we see that as I hover over different fields of a course, Joker gives us live feedback about the data that will be extracted. In this particular case, I'm interested in the prerequisite information. So I'll go ahead and click to confirm my extraction. And we see that the data is in a table augmentation on the website. What just happened here is that I gave Joker an example of one of the fields that I wanted to extract, and it generated a program that extracted all the prerequisite fields from all of the courses here. Now, if you're wondering what Joker did, or the program that Joker generated to do this, you don't have to, because if we click into a cell in the column, Joker shows us the program that it generated to extract all the prerequisites from all of the courses. And this program that it generated is fully editable. Now, taking a step back and thinking about this table is special in that it has set up a connection between itself and the website, such that operations that we perform on the table will be reflected in the website. And so if I, for example, sort this table, not only will this sort the values in the table, but it will also sort the corresponding values on the website. And if I go ahead and do that, we see that the table is sorted and the values on the corresponding values on the website are sorted. Now, thinking back to our original goal of sorting courses by whether they do not have any prerequisites, the task then becomes indicating for each course whether it does not have any prerequisite, and then sorting the column that that data will be in order to sort the table and then sort the website. We can do this by using one of Joker's processing formulas, or what we call augmentation formulas. And in this case, we can use a formula known as includes. And as we reference column A, which contains the prerequisite information, we can simply check for values that include none. And this gives us a new column that indicates whether a course has a prerequisite or not. And now, given this column, all I need to do to sort the list of courses by whether they have a prerequisite or not is by just simply sorting the table. We were able to achieve our task in a few simple and easy steps without having to resort to JavaScript. Now, at this point, I might want to also sort the courses by whether they have a prerequisite and are offered in the spring. With Joker, I can simply go back to the website and collect the information I need, in this case, the term information, and then perform an augmentation on the data to indicate whether the course is offered in the spring, and then perform a final augmentation to indicate whether a course does not have any prerequisites and is offered in the spring. Now that I have the term information in a column, what I can do here is that because these extraction operations or formulas such as query selector are formulas as well, I can simply compose the operations as opposed to creating a new column to do that. And so in this case, I can compose the includes formula again, and then just check if the values include the word spring. And then finally, we can use the AND augmentation formula that will AND the values from B, which tell us if a course does not have any prerequisites, and the values in the column C, which we just created. And just like that, we have this column which tells us whether a course does not have any prerequisites and is offered in the spring. And again, we can go ahead and sort the table. If we we sort the table to sort the values in the table and also the values, the courses in the website. Now, this approach works great if the data that we need to collect or extract can be extracted via demonstration or via selection. But that's not always the case. And I'll show another example that highlights this case. Here, we are on eBay's search results page, and we see that we have a Joker table, which has a column with URLs. Again, you might be wondering how we got these URLs, because even though we know that each product has a related URL, we can't select or demonstrate it because it's not visible. This is possible because the data extraction formulas that Joker provides, in this case, the query selector formula, return DOM elements, which in Joker are primitives like strings and numbers. This allows us to define operations on DOM elements. And in this particular case, we would have to traverse up the DOM node using the get parent formula. And then we have a get attribute formula, which gets the href attribute off of the link element where the URL is found. And with this, we see that Joker's approach is flexible enough to support complex extractions. Going back to the slides. At a high level, Joker is a Chrome browser extension that implements our idea of a unified interaction model for web customization. Web customization typically involves data extraction and data augmentation operations, where data extraction is simply the process of collecting data from a website, and the data augmentation is the process of augmenting or processing the data that we collect from websites. Existing approaches to web customization require users to perform all of the data extraction tasks before any augmentations can take place, which in some sense is a big limitation. If we look back at the MIT course catalog demo, in which I extracted the prerequisite information and then performed some operations on it, and then realized that I needed to extract the term information, with existing web scraping approaches, I would have to restart the process and extract the prerequisite information and then the term information before I can perform any augmentations on that data to achieve my web customization. Joker aims to make web customization easier by making the extraction and augmentation uniform and therefore more flexible. And our hypothesis is that this will make web customization tasks that involve complex operations much easier, because users will be able to mix and match or interleave extraction and augmentation operations to build incremental solutions or make incremental progress towards their goals, instead of being required to think about everything they need to do upfront. Joker's idea of this unified interaction model has two key concepts. The first concept is that extraction and augmentation operations are both spreadsheet-like formulas, and this we saw in MIT's course catalog demo. What this gives us is that formulas can be composed, which gives users more flexibility in how they wish to define the operations instead of being forced to do things one way. The second benefit of this is that we can then define operations on DOM elements, which enable more complex extractions when simply demonstrating or selecting is not possible. The second key concept with Joker is that extraction operations can be generated from demonstrations. And again, as we saw in the demo, users, or I demonstrated an example of a value to extract, and Joker not only generated a program to perform the extraction, but also made it visible and fully editable, giving me some insight into what it did, and also giving me the opportunity to modify it if needed. To evaluate Joker, we conducted a 5-person formative user study with the aim being to get some initial feedback about its usability. When it came to extracting simple data, all of our participants were able to achieve the task very simply and very quickly. When it came to extracting complex data, as is the case on the eBay search results demo that I showed, it was no surprise that users that are not familiar with HTML struggled. On the plus side, the users that were familiar with HTML and CSS commented on how Joker's approach was faster and easier than the traditional approach of writing web scraping code in an IDE outside of the browser. When it came to mixing data extraction and augmentation operations towards the goal of completing a web customization task, we saw that most of our participants took advantage of this feature, but we still need to perform more rigorous tests to validate this. In summary, Joker is a Chrome browser extension that implements our idea of a unified interaction model for web customization. And our overall aim is to make web customization easier by making the underlying processes more flexible, where the underlying process consists of data augmentation, data extraction, and data augmentation, which in existing tools, users are forced to perform all of their extractions before they can perform any of the augmentations. The two key concepts underlying Joker are that extraction and augmentation operations are both represented as formulas, and that extraction operations can be generated from user demonstrations and are fully editable. And as we go into the question and answer section, I would like you to think about what you like about these ideas and how some of these ideas can apply to your own work. Thank you.
Kapaya. If you have a question in the room, you can, Michael will come around. It looks like we have one from Justin. You may have to hold the button. Not yet. You have to hold it for a second.
Hello?
There we go.
Awesome. Awesome. Thank you so much. That was such a great talk. One question that I had is, what if the structure of the HTML is non-uniform? So you can't have like one query that will apply to everything based on one demonstration.
Yeah, that's a good question, and it is a limitation that we mention in our paper, because the process in which, as you saw, that we determine row elements from columns relies on a heuristic that depends on basically what you outline. So you can read our paper and learn more about that particular limitation and some of the other limitations that prevent this approach from working on every website.
Cool. Yeah. Thank you. I still really love it.
Thank you.
Not really a question, but some people on Discord have noted that you could add the ability to add asserts in your little window at the bottom there, and you can turn it into a web testing tool.
Oh yeah, that's a great idea. We actually haven't thought about that, but we'll take note of that and think about what's possible.
Okay, Jens has a question, and then we'll go back to the room.
Yeah, thank you for this very nice enhancement on your previous work and of your group. And I was wondering, does the query affect a column, or just is it a column, or is it on a cell level where you specify the query like in Excel on a cell level?
Yeah, that's a good question. So in our current implementation, the formulas affect the whole column. And so right now it's not possible to define formulas that affect a particular cell, but for the use cases that we're thinking about, defining formulas that affect the entire columns have been sufficient so far.
I remember that in previous work, you were able to customize a website by maybe adding per column or per entity, like new data. So when you say, make a note for that course, I already checked this, or I want to choose this and that. Can you do it indirectly with this method, or do you need this per cell?
So in that is a good question, and you're referring to Wildcard, which is the browser extension that Joker builds on top of, and that is possible in Wildcard because the operations are defined manually using JavaScript. But for this approach, where we put user demonstrations on the forefront, we haven't yet figured out a good way in which a user can define where they want the augmentations to go. But that's definitely a good thing to think about.
Thank you very much.
All right, Josh has a question.
Yeah, thanks for the presentation. Joker looks very useful. Can Joker currently be used with JavaScript front-end frameworks that are expecting to control the DOM themselves?
JavaScript used, can you clarify what you mean by, like, used it in what ways?
So say the web page you're interacting with is rendered by React, and React is expecting to make a lot of DOM updates, maybe in between when you're running Joker operations.
Oh, I see. Yeah. So that is another limitation in that essentially the data that we scrape is based on the state in which the page was when the script was run. So yeah, in the case in which we have React and virtual DOM, things get a bit more complicated, and this approach works best on static websites or data with or websites with static data.
Thank you.
Jess asks, is it available in the Chrome Web Store yet?
Not yet, unfortunately, but we are working towards that, and you can visit our page at MIT's Software Design Group to get information about when it will become available.
All right, thanks. And then last question from Mariano. How does it know what parent node to sort by? Can it be customized? Because you have to, there's like a sort container, like how does it know where the container is?
the sort container. So right now the sorting is done on a per column basis, if that makes sense. But and again, there's more information in the paper, but with each, the table essentially collects all of the DOM nodes that make up the row elements. And when you perform a sort operation, we move things around. So I think looking at our paper will probably give you a lot more information than I can provide given the time.
All right, let's thank Kapaya again.